Welcome to the Computer Science Igcse lessons, and we are on chapter number 1, compression tools. In compression tools, we are performing the topic of RLE, run, length, encoding. RLE is an example of lossless. In RLE, the first thing what I teach you is that the ASCII codes. The student have to remember the ASCII codes. So on my right hand side, you can see there are some ASCII codes for A, B, C, D, E, F. So we consider the decimal denary ASCII codes, not hexa. So the thing is very simple. Let me explain you again that we have A. How many A's are there?
5.
5 A's. What is the ASCII code for A?
97.
97, right? Okay. Now, let's talk about B. How many B's are there?
4 B's.
And what is the ASCII code?
98.
Then 2 for C and 5 for D. Now, can you tell me how many bits all are together here? If you're counting 5 plus 4, 9, 9 plus 2, 11, 11 plus 5, 16.
16.
Right? So we counted it in bytes. So how many bytes are there? 16 bytes.
16.
Okay. 16 bytes. So this means we have 5 characters with ASCII code 97, 4 characters with ASCII code 98, blah, 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 till 100. Assuming each number in the second row require 1 byte of memory, the RLE code will need 8 bytes. Let's count the below one. This is 1. This counted as 1. This will count as 2. This will count as 3.
3.
This will count as
4.
This one 5, 6. This one 7 and 8. So how many bytes are there?
8 bytes.
Now, are you agree that the data is compressed from 16 bytes to 8 bytes?
Yes.
This is the work of RLE. So this is half the original file size. So this method in which you're going to cut down the number of bytes approximate half of a size is RLE method for the text. Is that okay?
Yes.
Okay. So let's do some other thing like ASCII code for 65, 66. They are talking about this one. So you need to remind these codes. So each of these ASCII codes takes up 7 bits and there are 6 codes. This means RLE sequence to just take up 42 bits. So it's not necessary. It's not necessary. The thing which I told you is up there. Okay. So let's do something. Just a second. I just wanted to give you another example of RLE. So I'm working on it. Yes, I have another one. Fine. This work. Wait. Let me delete this one. Let me add something new from here. Just explaining. And there we go. Okay, so we have another example here. You can see we have number of A's here, B's here, C, D, E, again, D, C, D, E, right? Is that okay?
Yeah.
Can you count me the value of A? How many A's are there?
8 A's.
Very good. 8, okay. How many B's are there?
10.
8 plus 10?
18.
Great. How many C's are there?
1,
So 19, 20, 21, 22, come on, 23,
23,
24,
24,
and 8. So how many bytes?
32.
32 bytes. So I'm just writing BY, okay? Because I am short of space. BY, bytes, okay? Now,
Okay.
8 are the numbers and 97 is a decimal value for the ASCII codes. For A, you have to remember it now, okay? Then 10, 98, 1 for 99, C, 1 for 100, 1 again 99, 1 again 100, 1 again 99, 1 again 100, 8 for 1. Is that okay or not okay?
Okay.
Can you count the number of bytes down there? So this one 2,
18.
6, yes, 18. So what do you think? What is the original size of your data? See,
Original is 32
what is the compressed?
to 18.
18 bytes, right? So in this way, you're going to reduce the file size of the RLE compressed data. So you need to write down this whole example. You just need to write down this one along with the example. No need to write this one. You can just write it in your own wording, right? And once you're done with it, let me know. So I will give you this in homework. So I will send a screenshot to you. You have to do this one. And please make a ASCII chart like I have drawn it for you right here. You need to draw it till E, F, G, till G, okay? Like this.
Okay.
And send me the pictures. I'm waiting.
Okay.
Oh, yes.
I send you a picture.
Yes, I have sent you the picture.
Okay.
Check. Have you get it?
Yeah, I received it.
Great. Okay, now the topic about RLE is done, and we are going to continue some other examples. That's called MP3. MP3 word is very common. Did you know, where did you listen this word or hear this word before? MP3. Like, did you listen songs?
Yes.
Yes. Did you ever notice that in every song you see the word .mp3?
Yeah.
Yes, it means that that particular word is going to show the format of the song. Like, listen, like if you're listening a song and the song name is like uh, ABC, right? A, B, C dot MP3. This is a file. This is a file name. So this one is a file name and this one is a format, file format. So MP3 is specifically used for which files? Which type of files? Audio files. Audio files now. Audio files. Look. Like only songs are appearing in this format, MP3. So MP3 or MPEG3 uses technology known as audio compression to convert music and other sounds into MP3 file format. Like if you have a song file of 15 MB, 15 MB. So this compression tool is going to convert your audio file into 6 MB. And you can see the format name .mp3 after the name of the file. So this compression technology will reduce the size of a normal music file by about 90%. What do you think? Like 15 MB till 6 MB. So it's a huge difference. So this is how the compression tool for the audio work. For example, an 80 MB music CD can be reduced to 8 MB using the MP3 technology. But Fatma, there is a question in my mind. The question is, what do you think? Does it affect the quality of the sound?
I think yes.
Yeah, of course. Because if you are going to shrink the size of a file, so it definitely affect on the quality of the sound as well. So the quality of the sound matters, right? Sometimes we hear the songs with the beautiful beats in it, music beats, right? And you are having a headphone in your home and you listen the songs and you enjoy the songs music, right? But if we are going to compress the song, it definitely affect the quality of the sound, right?
Yes.
Yes. So MP3 files are used in where? MP3 players. Do you have MP3 player? Do you have it?
Yeah.
MP3 player. Okay. Computers or mobile phones. Files can be downloaded from the internet or CDs can be converted to MP3 format. Yes, the songs which you downloaded from the internet is also in a format of what? MP?
MP3.
Yes. Do you want to try? You can download the song, right? Any song. So you will come to know that the teacher is right, that the songs will be downloaded in MP3 format. Okay. So the CD files are converted using the file compression software. So MP3 is a compression tool for the sounds, right? Whilst the music quality can never match the full version of the found on the CD. Yes, the sound quality is different, the real one and the compressed one. But the quality is satisfactory for most general purpose. Like you enjoy the songs, the compressed files, because the sound quality is better. It is not, do not match the quality of the original file with the compressed file, but the compressed one is better. Is that okay?
Yes.
So we are learning the lossy format, right? So MP3 is example of lossy format. Since part of the original file is lost following the compression algorithm. Like I told you now that in lossy format, the unnecessary data will be deleted, right? So the same thing is applying here. The original file is lost, right? And the new file will be converted. This means that the original file can't be put back together again. However, even the quality of the MP3 files can be different since it depends on the bit rate. So I told you the quality is affected, and I told you the original file will be lost forever if you're using a lossy format. Any confusion?
No, no confusion.
Take out your notebook, you need to write 4 points on MP3. I'm just zooming in. Yes. Start now.
Okay, should I do this on a newer page?
Yeah, you can write it on page.
Okay.
Yes, you need MP4. So MPEG4 or MP4 files are slightly different to MP3. Any idea? Like MP4, what are MP4? Like you, yeah, come on, come on. Did you watch
I
video?
think,
Yeah.
I think I saw them like sometimes when I download the videos, then I see
Very
the
good.
MP3.
Like whatever the videos, movies you're downloading from the internet are in a form of MP4. So MP4 supports video, sound, music, photos, and animation. All things come under one word. So they all can be stored in MP4 videos. For example, could be streamed over the internet using the MP4 format without losing any real discernible quality, right?
Yes.
Yes, I'm sending it to you. I have done it. So MP4 is done. Now JPEG. I think you're very familiar with this word, JPEG. What do you think? What is JPEG? I think it's a very common word. Like whatever the pictures are stored in your mobile phone are always in a form of JPEG. Check your pictures in your phone. They all have that image.jpeg, image1.jpeg. Check, isn't it? So
Yes.
that is used for pictures. The pictures stored in your phone, in your computer, in your tablet, wherever, it's always in a JPEG form. So when camera takes a photographs, it produces a raw bitmap file, which can be very large in size. Like whatever the picture you're taking from your camera, that picture is in a bitmap file. Bitmap. Remember? Bitmap topic we have done. So
Yes.
bitmap are very big. So these files are temporary in nature. JPEG is a lossy file compression algorithm used for bitmap images. So the big pictures, the big files are going to be compressed into a small file size with the help of a compression. That compression tool is called JPEG. What it called?
JPEG.
Do you know the full form of JPEG?
No.
No problem. Now, did you know? Joint Photographic Expert Group. So this is a full form of JPEG. What do you think? Joint, come on, Photographic
Expert group.
Yes. Now now you know the full form of JPEG, so you can ask your friends that what is the full form of JPEG, and obviously they don't know that, right? Okay. So JPEG is a lossy file compression. It makes the images smaller. It is going to compress a file just like we have done MP3, we have done MP4, right?
Yes.
Oh, yes. The JPEG file reduction process is based on two key concepts. So there are two concepts, right? Number one, human eye don't detect differences in color shades, quite as well as they detect differences in image brightness. Do you remember in the last lesson I have shown you two pictures?
Oh, yeah.
Did you notice the differences between them?
Yes.
Yes, because both pictures are in front of you. So I realize you the differences in the sky, in the clouds, isn't it?
Yes.
But if I'm going to show you only one picture at a time and then another picture, I'm sure you're not able to detect the difference. So the human eye, our human eye is not going to detect the less sensitive color things. Number two, by separating pixel color from brightness, images can be split up into 8 into 8 pixel blocks. Like this is an image, look. 8 into 8 means 8 columns. And how many rows? 8 rows. Got it? 8 columns into 8 rows. These are not 8. I just telling you the concept. 8 into 8. Just like that. Boxes. So what happened? By separating pixel color from brightness, images can be split up into 8 into 8 blocks, for example, which allow certain information to be discarded from the image without causing any real noticeable deterioration into quality. Like if you're changing the color of an image, the image color will be different into 8 pixels, then 8 pixels and 8 pixels. So this is a very minor change and the quality of the picture remains same. It does not affect the quality. Like you are not able to notice it. The basic concept is that the user is not going to notice it because the change is very minor, right? So this is called JPEG. So take out your notebook, make 4 points on JPEG and send me the picture. I'm waiting. Look, we have done this topic with RLE on text data, remember? This topic is done, right?
Yes.
This is for the data, text data. Now we are starting it for the images. So did you see this black color F?
Yes.
Okay. So we have two colors right here, black and white, isn't it?
Yes.
So a white square has a value of 1 and the black square a value of
0.
and every square is of
1 byte.
can you count it for me? 1,
2, 3, 4.
4, 5, 6, 7, 8. So how many bytes are there?
8 bytes.
8 bytes in a row. Is that okay?
Yes.
Can you count it for a column?
1, 2, 3, 4, 5, 6, 7, 8.
So 8 for the column. So what is the total number of bytes?
8 times 8.
8 into 8. Can you tell me the total value for the bytes?
64.
64 bytes. I'm just writing BY, okay?
Okay.
Okay, great. Now, what I teach you, that 1 for the white color and 0